So nice to
Sounds
meet you,
great.
Rainer.
All
All
right.
right, let me fire into this. I'll give you a quick introduction to me before I head into the presentation. So I'm Chris Brown. You can see on the screen. I'm the Chief Operating Officer at a company called Intelygenz. I'll tell you all about what Intelygenz do and some of the use cases that we perform with some of our global customers. I spent 15 years in telco, across British Telecom, via Intercom when I was in Munich, and before it became O2, and then with Vodafone. Actually, I spent 15 years with Vodafone, so I probably spent 20 years in telco. I'm so old now. Anyway, it doesn't matter. 20 years in telco. I left about 4 years ago to join a company called Intelygenz. They were a supplier to me. I was the head of global innovation for Vodafone. So all new product for global enterprise businesses were flowing through me, and Intelygenz were a supplier, and they were just fantastic, absolutely excellent supplier. We built some incredible products together for Vodafone, and I was sitting with the CEO one day and I was like, what are you doing with this business? Where are you going to take it? It's an amazing business. What are you doing? He was in California at the time. He's back in Madrid right now. And we were just chatting, and he's like, well, if you think it's so good, why don't you come and do that? And I was like, nah, no thanks. I'm all right in my corporate world. Thank you very much. Anyway, here I am, 4 years later in Intelygenz. And it's been a hell of a ride, We're a completely different company from when I joined 4 years ago, and we're doing some incredible projects around the world, predominantly with the application of artificial intelligence into production. Something that you hear a lot about, and you see a lot of TV adverts from large organizations about the application of AI, but the reality is getting AI out of the lab and into production, where it can really generate some value for a business. Less than 14% of organizations that attempt to put AI into production ever make it. That's a Forbes piece. And we're super proud that our clients are part of that 14%, because we bridge the chasm of getting AI out of the lab and into production systems, and clients using it every day, because it's not just the technology you need, and the technology is important. And when I say that, the data science is important, but you also need to meet data science with engineering and agile teams in order to engineer that science. Data scientists don't put anything in production, right? They create incredible theories. They're scientists. They create incredible theories and data models. But whether they can be engineered commercially is a completely different matter with the compute power that's available. And bridging that chasm is important. And then another really important element of that is managing the human change required within organizations when you apply artificial intelligence. Obviously, the whole fear of, you've seen it across LinkedIn and all social media about AI taking people's jobs. And the reality is AI doesn't take that many jobs. Automation takes a shit ton of jobs, takes billions of jobs around the world, right, away. But we don't talk about that, because as humans, we've been automating for a very, very long time, and the majority of what we do as a business is automate. But AI is not about removing people's jobs. It's about augmenting intelligence and augmenting decisions and creating capacity, and that's what we do. So let me show you. I'm based on the West Coast. I said that earlier, but I'm from the northeast of England originally. So I'm from Newcastle in the northeast of England. I moved over to the US about 6 years ago with Vodafone to lead the global innovation practice out here. I've been here ever since, coping with COVID and fires this year. It's been a very, very interesting year, and I'll be happy to see 2021. I'll tell you, and I'm sure the kids will too, as we said. So I'm glad everyone's on the call. It's lovely to feel some global interaction, because you sit in the house and you become very insular very quickly. So it's very nice to speak to people around the world. And Nikki, thank you for convening these guys together and such a huge amount of eclectic mix of huge intelligence. So it's a pleasure to be here. So let me. I think normally what I do with Nikki, as he knows here, is I'll give you a very short introduction into Intelygenz, but the majority is I like to just give some use cases and examples of of where you can apply AI, how to look for applications of AI, what Hollywood versus reality looks like. You know, what does Westworld look like versus really putting AI into an enterprise business and making a success of the tools and technology that exist today. So let me start at the beginning of who. Any questions, by the way, right before I start? I'm happy to take any interruptions and questions as we go through. Much rather have a conversation as always, but if there's anything that you guys want to talk about, then happy to hear.
Hi, Chris.
Hello.
Hello, Emilio here. Is this like a robotic process automation, or is another spin on the subject?
So no, actually, it's quite an interesting question that you would go so quickly into RPA. RPA owns the automation space in terms of marketing, but in terms of using an RPA tool, it's a super niche place where RPA is really the right answer, right? And that's a whole topic on itself.
Sorry, Chris, what is RPA?
Robotic process automation.
Oh, thank you.
So another phenomenal question, Marcus, right? So what is RPA? So if you ask me, it's different to what is marketed as RPA. RPA is any kind of compute program that can automate a process, yeah? But in the real world where people talk about RPA, it's a set of platforms and tools that promise to automate your processes where no coding is required, and it enables clicks. It can record clicks on your computer screen, and then it can repeat those clicks as if a human's making the clicks and the human's not making the clicks. But actually, it turns out to be a pretty fragile scenario and a pretty expensive implementation. But we do automate process. We spend the majority of our time automating process, but we spend a fraction of the time automating those processes with an RPA platform, because we quite frankly, we don't see that solution being the best solution that an organization can take the majority of the time. We're agnostic. I'm not against RPA tools. Sometimes they're the right answer, but very often they're not. So we spend less than 5% of our time implementing RPA. Well, we spend 100% of our time implementing RPA in my definition, but in the market definition of RPA, we spend about 5% of our time. But great question. As I say, I can't believe that was the first question. I haven't even talked about automating in RPA yet, but it's probably one of the most detailed questions you can ask on process automation. So a little bit. Any other questions, by the way? And I don't have a hard stop, Nikki, unless you give me one, by the way. So you tell me.
I'm good. There's no session after yours. So.
Okay, I know people are in Europe though, so it's getting late. So let me be at least as concise as I can be. It's not a top skill of mine. So Intelygenz, we're 20 years old. We were founded in Madrid 20 years ago by 3 Spaniards and a French guy who still wholly own the company. We bootstrapped our company for the past 20 years together. We opened our offices on the West Coast in 2011, so we've been in the US for 9 years. Our business is split across Europe and the US as 2 predominant markets. We've got a little bit of business in Asia, not a lot. A little bit in LATAM and Chile, but not a lot. Nothing in Africa at all. We've got a partnership down in South Africa, but it's very early days. So really, 95% of our business is across North America and Europe. Split 50-50. We're about 180 people. 95% of those people are software engineers. We're an extremely technical organization. And we've been deploying production software for predominantly large enterprises, not always, but predominantly large enterprises for the last 20 years. About 5 years ago, we got quite a wide technology stack. So we do everything from front-end native applications on mobile devices, all the way through to back-end architectures, and on multiple different platforms of Java, Node.js, Python, if anyone's interested in language. So pretty wide tech stack. And we introduced about 5 years ago artificial intelligence into our technology stack. At first, we created an entirely new practice in order to deploy AI. We're just starting to blend that back into and fold it back into our organization as just another part of the tech stack, because we believe that that's how it should evolve. So we purposely kept it separate because we wanted to focus on it was a completely new set of skills, a completely new process in terms of implementing it with clients. And so we ran it as a separate business, and we're now folding that back in, ready for expansion and growth right now. And the major difference that we found with AI deployment, not only the technology skills, which is a difference, right? And we had to hone in on those skills. Data scientists are very different to software engineers. They're very technical people, but they're a different breed. Was the approach with clients, in that we've got 100% track record of delivering our software to clients, and at the start of every software project, you know you're going to deliver it. You might be a week early, you might be a week late, but you're going to deliver it. And with AI, it's very, very different, because the answers to nearly every question you ask at the beginning of an artificial intelligence project is, I don't know. I don't know the answer to that question. Do I have enough data? I don't know. Is my data correlated? I don't know. Is it clean enough? I don't know. What compute power do you need for this? I don't know. What accuracy do you think we can achieve? I don't know. How fast can you process it? I don't know. Right? The answer is just, I don't know. Right? Because you don't know. And that's very, very different for a client to try and absorb a project. Say, well, hold on, it's going to cost me X amount of thousands of dollars to go through this process, and you're telling me you don't know it. What? Well, why am I going to work with you then? Right? So it's a fundamentally different process you need to take a client through. And we've had to define and refine that process. And it's been a big critical part of our success, because you've got to mitigate the risk of time and financial investment in that project to take your customer on that journey and convince them that no matter who you speak to, the answers to those questions are you don't know. And if anybody answers that question in a different way, be really suspicious, because they don't know, right? They don't know, because they've never seen your data, and they don't know what specific question you're trying to answer. So it has to be, I don't know, but we have a process to take people through. So that's a little bit about what we do in Intelygenz. In terms of, all right, the logo slide, but forget the logos. We deal with large enterprise. All our clients, or majority of our clients, tend to be significantly bigger than we are. We've deployed everything across a lot of industries, right? One of our biggest challenges, and the reason I was slightly late to this was coming off a marketing call. I'm responsible for running marketing as well as part of my day-to-day operations, was what's our target industry, right? And we've been spinning around this for 5 years, and the answer is we don't care, quite frankly. We're not the domain experts in any industry. We don't profess to be, but if you have data and you want to find answers from that data, and you believe those answers can create enormous value for your business, then you should be speaking to somebody like us, right? Either us, we'd love it to be us, but somebody like us that can find those answers. And we've done lots of non-AI projects, of course, over the previous 15 years, where we've delivered everything from sound applications for Dolby, back-end banking applications for global top 10 banks, ledger systems, really business critical. Where we perform, we're in business critical platforms and services and processes for our clients. Advertising, someone talked about, was it Rainer? You talked about advertising. We've done marketing and advertising campaigns for MTV and Disney and lots of different things. But where it's involves the building of software, and predominantly now in the application of artificial intelligence, then we have a part to play in that journey for our clients to extract that value. If you look at all of our use cases, and we just started to boil this down, this is new, Nikki, I don't think you've actually seen this. We predominantly do two things, right? It doesn't matter what industry, it doesn't matter how you look at it or how you talk about it. We only do two things. We automate process and we build product, transformational digital product. And on occasion, more and more often now, we elevate both of those to intelligent process automation and intelligent product through the application of artificial intelligence into that process. I'm going to talk a little bit about automation today, because this is where the majority, I don't know if it's a COVID world, or whether this is really where people are starting to really latch on to AI. I'm still working through that right now. But the majority of our clients right now, intelligent process automation is where the hot topic is. And I'm not going to run through process because I don't have time. Businesses run on process, input, output, action. I will focus on this slide. The difference between process automation and intelligent process automation, yep, we can talk about it in one. One is about applying AI within that process, and the other one is not using AI. But the difference from a customer position and an operational position is process automation automates tasks that don't need any form of complex decision. Sure, there might be some if then else statements, if this then that, some case switches, right? Some very simple basic decisions on very structured data. But on the whole, it automates task. What intelligent process automation enables you to do is automate task and decision within that process. So ordinarily in a process where you've automated or you haven't automated any process, there'll be a point where you need to make a decision within that process, where you need to apply human cognitive capabilities in order to say, what shall I do next within this process? It's not just a simple task. I need to collate all of this data and apply my knowledge and experience and talent in order to understand what to do next. And as humans, we do that fairly easily, and maybe we don't think about it in those large dynamics and those large words because we've got great brains and we apply that process. And by applying artificial intelligence, what you allow it to do is to start to automate some of those processes some of those decisions within the process. And what that enables you to do is to automate much more complex, much wider breadth, longer strings of process that can really fundamentally change a business. Things that look like this. This is a real process map actually from one of our clients. And you don't have to read it, forget about reading it, but other than everything in blue, we don't need any AI to move the process along. But as soon as you hit one of those green circles, you need to make a decision in where you're going to automate your process. So if we do process automation for this particular client, we can automate A to B and we can automate C to D. But what we couldn't do without artificial intelligence is automate A to D, right? And that can sometimes fundamentally and very often fundamentally change a business's ability to operate. I'll come back to this. I talked about the process. I could talk about this for the whole hour. I'm not going to. It's incredibly important in getting you from I don't know and into production. But it can be quite boring. It's really important, but it can be quite boring to talk about. So I'll come back to that if you guys are interested. On the whole, when we're automating process, there's three major value benefits that our clients are looking to extract. So we're an extremely technical organization, but our focus is always on commercial return. So there's no technology for technology's sake. There's no technology to do an exercise of on with greater technology. Right? We run on, I said we bootstrapped our business for 20 years, no investment. So we run on happy clients. And we run on the ability to keep clients and make sure they stay with us. And most of our clients have been with us for 15, 20 years. We rarely lose a client. And that's because you have to focus on commercial return. And the best thing about process automation, very, very, very predictable, very measurable returns. I often tell a story of when I was in Vodafone, and one of my previous roles before I moved to the US was I looked after all of the capital investment for Vodafone UK. So there's about $3 or $4 billion in capital investment each year. And what would happen, business units would come and pitch why they needed all this money. And then you'd sit on the board. It was a bit like Dragon's Den or Shark Tank for those, right? It was a bit like that. Who's going to get the money, right? And we had a pretty rough rule of thumb, which was if someone's coming from a marketing perspective and asking for money, we'll multiply their business case by 0.35, right? Because on average, you'll get about 35% of the returns on your growth across all of the cases. Some will blow the case out of the water, others will fail miserably. So you'll get about highly unpredictable, basically. Anyone that's coming with cost reduction, it's 95% that you multiply, right? Because humans are naturally optimistic. They probably overestimate it, but it's highly predictable. And that is what this story is playing out here. And these are the three hard impacts that our clients are looking for: reduce cost, increase capacity, or improve quality, often all three. There are some others around the edges that are just as important, a little bit more difficult to measure at the early stage of a project. Employee engagement, employee satisfaction, customer satisfaction, all of those pieces. because employees get better roles at the end of the day when you take some of the crap off their table, pardon my language. And you'll see in one of the examples I show in a second, it can fundamentally change the marketplace. You can fundamentally put offers into the market that economically were not available before, and you can change the standards within a market that are expected. And it can, and that is a super powerful place. But very often, it's not the first measure. These are the three things that clients are going for. Really quickly on this, what we're looking for is points of margin, right? I told you we're a pretty technical business, but our focus is commercial. When a business grows, which is the pinky purple line at the top, what often happens if you have manual process or very low automation, costs grow at exactly the same pace, right? And yes, on real numbers, you're growing your business, but your points of margin aren't changing. The gap between the pink and the purple and the white line aren't moving. And what automation allows you to do is start to take those costs under control, where scale and capacity become an automated process and allow you to create margins of margin business in the middle. In terms of the kinds of AI we do, you can see it on the screen here. I think the best thing for me to do is give you some examples, right? Is to give you some examples of what we do. The only one I'll pick out here is data augmentation. This has allowed us to really steal a margin in the marketplace, where the majority of challenge within an AI application is the lack of data and the expense of creating that data. And what we've spent a long time doing is building a lot of physics knowledge, physics modeling knowledge, and data augmentation skills in order to synthesize data cheaply, expand it greatly, and therefore enable applications to reach production that with real world data would take many, many years to get there, because achieving the data set is very difficult. And I've got an example of that as we go through. Any questions before I move into a couple of examples? I think examples bring it to life a little bit better.
Yes, Chris, I was curious, how do you advise clients about speed and capacity in a world that's reaching limits to growth in capitalism?
How do we advise clients? So we do very little advising, truthfully, right? Being totally truthfully. We have a very, very small consultancy practice on the front of our business, very new to us, right? We're a bunch of engineers, and our clients tend to come to us with where they want to improve their business, right? Where they want to improve their, where they think they have inefficiencies in their business, where there's a skills gap in the market, where the skills don't exist. They cannot hire from the street any further because those skills just fundamentally don't exist, right? There's not, they're not, and we could, by the way, we could wind that back into where is education and training, because automation is probably a big force of there aren't enough people that are skilled at this role, and therefore we're being forced into automation. I know there's a few educators on the call here, right? So we do very little advising other than process scoping. So our consultancy is extremely focused on, we can go in and look at process and understand what are your time, effort, and your response times look like. Where can automation help you? Our consultancy is extremely slim on the front end with that. So I think the real answer is we don't do a lot of advising of our clients, and it's something we're looking at as businesses from a point of view of how do we help our clients do the discovery piece. We've got one piece in our kit bag, which has got nothing to do with capitalism or any of that piece, but just looking at from an advice point of view of how we help our clients. We knew we weren't consultants, right? I go back to that introduction. We're all software engineers, right? And we knew we weren't consultants. So how do we help our clients understand where they can take efficiencies from the technology that's available? And we could either build a consultancy practice, which we didn't feel was a natural fit for us at that time, and we're still battling that a little bit. But what we did do is we created something called our AI Academy, where we would go in and we would teach people about what the capabilities of AI were, what you could achieve, what Hollywood, I talked about before, what Hollywood versus reality. How do you start on the journey? How do you discover places in your organization where artificial intelligence can generate benefit, right? Both for the employee and for the financials of the business. And we've run that successfully, and we've got a few versions of it, everything from 4 hours to 3 days of an academy. And that has been a big part to play in our front end engagement with our clients. But in terms of when do we talk about capitalism and worldly impact of how you gain more efficiencies in that space, there are so many efficiencies still left to achieve in the world. Then we really don't need to go that far and that deep to find them, quite frankly. There's so many places that don't have any efficiencies. Oh, I have a blue face. I don't know what that means.
I'm smiling at your answer. Thank you.
Oh, you're smiling at my answer. It wasn't a very good answer. We don't do much advice is the real answer. We do execution. We're much more of an execution company than an advice company. We leave, oh, I could go on. I just came out of that meeting with marketing of where are we versus an Accenture or a KPMG, because these guys will go in and they'll build PowerPoint till they're blue in the face with you, right? And we don't do that. We don't build PowerPoint for clients, right? We just don't do it. And we're having this whole internal debate of, do we need to go and build PowerPoint? And we're all as software engineers shivering saying, oh, I don't want to build PowerPoint. I don't want to build PowerPoint. But if we don't help our clients understand, then how do we grow the business? But yeah, you'll always get a truthful answer from me. And it's not necessarily a PC answer or an intellectual answer, but it's the truth, right, of where we're at in terms of our business. We execute, and we really need our clients to understand what they want to execute for us to come in and make that happen for them. Let me talk about this one. This is a great data synthesization example, and I talked about it being a big part to play in AI. Because where data is scarce, and you don't often hear that, right? Data is scarce. Everyone talks about how many petabytes of data we're creating in the world, but we don't talk about the usefulness of that data and how useful it is and how to extract value, because a lot of problems that we come across actually have scarce data, not too much data. We were asked for a Silicon Valley chip manufacturer. I wish I could name them, but one of the issues of being small and dealing with big companies is big company lawyers and marketing teams that don't let you use their name on slides. So I'm gonna adhere to that rule because it's important to us from our compliance point of view. But a really large chip manufacturer here in the Valley, very traditional chip manufacturer. In fact, they put the RF antennas into probably most of the mobile phones that are sitting on your desk right now, and they had a system. And I said we're not domain experts, but you learn a lot in this role, right? Because you become enough domain knowledge to be dangerous, and we learn a lot of really interesting stuff with our clients. And they have a manufacturing process on the silicon, and what they do is they look for cracks in that silicon using infrared images. And that was completely fine. It's working all great. But as time moved on and chips needed to become smaller and smaller because they needed more componentry, and devices were squeezing more capability, and therefore they needed smaller chips in order to get that capability in. They had to employ a technique called backside grinding. If you don't know what that is, neither did I, don't worry about it, right? But actually they just physically scrape the silicon die once the chip's been created. They physically scrape the back of it to make it thinner, right? And what that does is two things. One is it has the potential to create cracks in the silicon. And the second thing, and the most difficult thing, is it hides the cracks in the silicon from the vision system. So the cracks become, the scars on the backside grinding start to look like cracks within the silicon die. And what happens is their vision system that was looking for cracks starts to over reject components. And that's a very expensive issue, in the hundreds of millions of dollars expensive issue, because the way the commercials work is if any cracks or any fault once it's in the supply chain of a mobile phone, they backward engineer the fault and they understand whose component failed, and the cost of that failure is enormous because it all goes back to the chip manufacturer. And it's not just the price of the chip, it's a huge long chain of costs, of supply costs that go back to the chip. So they have to have 0% flow of cracks through. So what happened was, this is what it looked like. And the top left is the old school. This was before backside grinding. That's a clean image. And this is a cracked die before backside grinding. Yeah. In the top right. Can you see my mouse pointer on the screen or not? Does that work or not on Zoom? Yeah.
Yes.
And what happens post backside grinding is these lines start to appear, as you can see. And the lines are hiding cracks. And there actually is a crack up here in this die. And the vision system rejects both of these, right? Because it says these lines are cracks. And of course, they're not cracks. They're backside grinding marks. And they try to modify it and modify it and modify it. And they're like, okay, we got a problem. We got a problem here. And they knew about us. And, you know, I talk about if you've got data and you think there's answers within that data, in their case, the data is an image, and you need to answer that question, then you should be trying to apply artificial intelligence. So they had pretty much three challenges, right? I talked about they need 0 false negatives. Their current levels rose to 12% of rejection. It used to be less than 1%. They need to get back to less than 1%. And the execution time, and this is where data science meets engineering I talked about before, you have to execute every image and make a decision in less than 0.4 seconds, right? Which means cloud deployment is not an option. So you don't have infinite compute power, and you have a manufacturing plant that you have to fit your compute power into. So your environment is constrained. And this is where, this is both a great example of data augmentation, but also having to bring engineers and data scientists together to iterate to a model that can actually be developed inside the constraints of the environment that you have to go for. So 3 major independent challenges. We had a huge amount of they were good at manufacturing, believe it or not. They're awesome. Of course they are. They've got 20, 40 years experience. They didn't have many cracked dies. So the amount of cracked dies that we had available to train an AI system on were tiny, absolutely tiny. So we could train a system to spot 3 images, no problem. That's called overfitting, right? It doesn't spot cracks, it spots 3 images, and only those 3 images. And unless you expand the amount of data, you can't, what you're looking for in an AI system is you need to generalize your answer. I don't need you to spot a particular image. I need you to spot a characteristic within that image that is the same, right? And for that, you need large amounts of data, and any anomaly issue, whether it's fraud or whether it's cracks or quality assurance, you have an anomaly problem, right? Because by definition, anomaly means it doesn't happen very often. So what are you going to do about that? The other issue was backside grinding scars look like real cracks to the current platform. So how are we going to solve that issue? And then the third one was we got to engineer it to the manufacturing plant. And therefore the science, if we can solve the science of 1 and 2, we've got to be able to engineer that science as well. And that's what we call bridging the chasm from the lab and into production, right? And that's where the 14% of companies are being successful. So how do we reduce the data imbalance? Actually, we did 2 things. This was the first attempt that we made, and it worked pretty well. Our data scientists started to do some really simple things. They started to break the image up into windows, and they then took those windows and they said, right, what we're going to do is we're going to use the detection on a window, not on the whole image, but on a window. And also on those windows, what we're going to do is some really simple things. We're going to rotate them. We're going to flip them. We're going to generate synthesized data from real data, right? And that gave us a 10 times augmentation rate. So it enabled us to get to a level of accuracy and generalization to identify cracks within the platform. But we went one step further because it got us so far, but we needed to, remember it's 0% and less than 1%, we needed to go further. So what we did is we started to work with physics models and be able to synthesize cracks. And we created a crack synthesizing tool, which would take a clean image as an input, and it would put random realistic cracks as an output overlaid on top of the image. And what we had to prove was, could we synthesize data realistically enough that we could train an AI model with that data and that it would be accurate enough to spot real world cracks. So we held all the real world cracks hidden, and we use that as what's called validation data. And we trained the model only with synthesized data. And then we ran every single real world crack image that we had to find out what our detection rate was. And it was highly accurate. So we'd proven the point that we could synthesize data accurate enough to train an AI to generalize and detect real world cracks. And that's a really big part of being it. And this is the data science world, right? Can you create the science that will synthesize this data? So that was the reduce the data and balance piece. Removing stripes from image. And it looks super simple when you do this, but remember, you've got infinite possibilities you can go for. This is what we did. And we created a second tool. So this is, remember, this is all before we even get to AI. No models, no models have happened right now, right? No AI model. It's all about data pre-processing. It's a really critical part of getting successful AI to work. What are the characteristics of the noise is where the scientists start to look at. What are the characteristics? Well, it's uniform, it's in one direction. Well, what can we do to remove that? And not only what are the characteristics of the noise, but what's the characteristics of the noise versus a crack? Well, actually, interesting enough, yeah, this is uniform, it's single direction. Cracks tend to spider, right? Or they tend to branch out in these ways. So can we detect regular noise, regular pattern? And it's not always in this direction, right? But whatever direction it's in, it's always uniform. So what we did is we created Fourier transforms of that image. We then mask the noise, and then we inverse Fourier transform the image, and it's then removed the noise, but the cracks will remain. Yes, it will remove the cracks that are in this direction, but no crack is in a single direction. So we know we're still going to have cracks left on the image. And that gave us a massive, massive uplift and benefit in being able to detect cracks. So it's all about data pre-processing versus AI. No AI happened right now. This is all about preparing the data to go into the machine. Yeah. And then when we use this is showing what we did when we used the window version. We trained the model on the windows. We then, in inference or runtime, we put the whole image in, we break it into windows, we run it through the model, and then the window predictions come back, and then we use statistical analysis on how many cracks out of the windows did it find, and then we can move that up and down in order to change our accuracy levels, and then you get the image prediction at the end of this, which is good or bad. All of the heavy lifting was in the data pre-processing in the science world. We automate all of our AI training in order to get the answers. Make sense? And then you've got to engineer it. That's all great, and this all worked beautifully when we're running it on the Amazon cloud with infinite compute power, right? But how do you get it to 0.4 seconds inside the manufacturing environment? So we had to find and go out and source hardware, edge compute. Found an amazing company called Rick Alignment for edge compute that was commercially okay. It worked within the platform, and then we go and we start to implement on premise to hit that 0.4 seconds. We put the model in, and you also have to take care of continuous training. So we need to make sure we can get access to the data. We understand the answers. We understand when we're right and wrong, and you have to create that feedback loop. And doing that in a manufacturing environment or any closed environment, it's pretty boring, but it's really critical, right? So it's not all fancy Westworld, right, AI. It's about being able to, how do I extract the data in real time in a world? How do I get through the firewall? Where do I put that? How do I get enough bandwidth and data in order to make sure the retraining is happening all of the time? And this is what we talk about, bridging that chasm, you know, from lab into engineering. So that's what we did, and that one's working pretty well. We're at 0.7 seconds right now, so you see we've got some work to do. We got some work to do on this, but that one is we're pretty confident that one's progressing very, very well. Any questions on that as an example? This is the kind of thing we do as a company, by the way. This is, you know, we don't build robots, and we don't have Ex Machina, but we answer very specific questions with very unstructured data for large enterprise problems where the answers have extremely high value.